Hey GeoData people, we are almost done with the geometry curriculum. So we are in Unit 5, Investigation 4, and we're going to look at some of the problems in Lessons 1 and 2 today. I should mention that before we do this lesson, we have already had some assignments in Khan Academy where he demonstrated inscribing a circle, drawing a circle inside a triangle where the circle touches all three sides of the triangle. And you also had a Desmos activity that you did in the last class that talked about inscribed and central angles, and you practiced comparing inscribed and central angles. So what we're doing in the lesson today is we're going to work with those concepts. So if you have not watched the Khan video and you have not done the Desmos activity, what we're doing in this lesson is going to move a little bit faster than it would if you had already done those previous assignments. All right, you can always go back and watch them later if you did not already do them. Okay, so we're starting on page 123, and this looks like a very complicated diagram, but it's actually very helpful because I can use it to demonstrate a lot of the things that we've already learned about. Okay, so let's see what they're telling us here. First thing that they tell us, we have this triangle, ABC, and inscribed inside that triangle, we have this circle. We call it circle D because the center is at point D, okay? And they give us a few of the measurements here. Okay, so let's see what they tell us. They tell us that the length from point C to point D is 13. So here's point C. D is the center of the circle. And so they've already told us that this length right here is 13. So I have that one marked in already. They also tell us that the distance DE, from point D to point E, this is point E, is 5 units long. And they tell us that the measurement of angle DBE, so that's this skinny angle over here, just the bottom part, is 15 degrees. And the last thing they tell us is that angle DAG up here at the top, D to A to G, so that's this angle here, they tell us that that angle is 52 degrees. And that is all they tell us, and they want us to figure out a whole bunch of other things. So the first thing they're asking us to find is what is the measure of angle EDB? Okay, so where is angle EDB? Well, that's from point E to point D to point B. So they want us to figure out what this angle is. Okay, from here to here. What is the measure of that angle? So we already know, if we look at this triangle here, I'll outline it. If we look at this triangle only, and we ignore the rest of the diagram for the moment, we already know this angle down here is 15 degrees. They told us that. You may recall that when you have a line that's tangent to the circle, that touches the circle at one point, a radius that goes from the center of the circle to that point of tangency is always going to be a 90-degree angle. So we know that that is a 90-degree angle. And we recall from our triangle work that the angles inside a triangle always sum to 180. So here's what we know. We know that all three angles in triangle EDB sum to 180 degrees. They add up to 180 degrees. We know two of the angles. We're only missing one angle. So if we take 180 degrees and we subtract the 90 and we subtract the 15, that's going to give us the remaining angle, which is 75 degrees. Okay, so now we know that angle EDB up here is 75 degrees. First one done. Let's see what the second question is. Well, now they want to know, what is angle ACB? So where is angle ACB? So we start at point A to C to B, all the way out here. So angle ACB is this angle here. They want to know how big is that angle. All right, so I'm going to outline the big triangle, and that's all we're going to look at is the giant big triangle. We're not going to worry about the circle. We're not going to worry about any of the smaller bits. Okay, just that giant big triangle from A to B to C. So what angle measurements do we know? Well, we know that this little skinny angle down here is 15. And we know that this angle here is 52. Now, another concept that we learned about in Mr. Khan's video, when you watched that one, was that when you have a circle inscribed in a triangle, if you draw segments from the center to those vertices of the triangle, it divides the angles exactly in half. They're called angle bisectors. What that means is that if this angle here is 15 degrees, this angle here is also 15 degrees. All right, so we know this angle is also 15 degrees. Same thing up here, okay? The circle's inscribed inside the triangle. If we draw a segment from the center to that vertex, whatever the angle on this side is, 52 degrees, it's going to be the same measurement on that side, 52 degrees. Okay? So that's actually very helpful because now we know that this total angle here is 15 and 15. And we know that this total angle here is 52 plus 52. Okay? And again, we know that the whole triangle has to add up to 180, right? So we have 180 for the whole triangle ABC, and we have to subtract 52 and 52, which is 104, and we have to subtract 15 and 15, which is 30. Okay, and so if you subtract 180 minus both of the 52 degree angles, or 104 degrees, and then you subtract both of the 15 degree angles, which is 30 degrees, turns out that this whole angle here is 46 degrees. Okay? All right. Third thing they're asking is, what is the measure of segment DF? So where is segment DF? Well, here's D, the center of the circle. Here's point F over here. And again, you may recall when there's a line that is tangent that touches that circle at one point, the shortest distance from the center to that line is the radius, and it's a right angle, and that's going to be the radius. And you know what? They already told us that this radius over here was 5. All the radiuses are the same. So DF is a radius. And we already know that that's 5. Okay. And the very last one is CG. So CG, I'll find another color here. So CG is this distance here. They just want to know what that distance right there is. I'll just call that X. Okay. Well, look at what we already know, you guys. We already know this one is 13, right? They told us that. And if you remember, this is a line that's tangent, so we can draw the radius from the center to that point, and that's going to be a right angle. Look at what we have there. If you can't see, you can always turn a paper around, but can you see that's just a right triangle with a 90-degree angle. So we can use our favorite a squared plus b squared equals c squared, right? We know this is the radius. We know that's 5. This is the hypotenuse. It's the long slanty side. It's opposite from the right angle. And the missing side is one of the other legs. So we know a squared plus b squared equals c squared, right? A is one of the legs, 5. B is one of the legs, x. 5 squared plus x squared. And we know our hypotenuse, C, is 13. Okay, so 25 plus x squared is 169. Subtract 25. X squared is 144. By now, you're probably starting to memorize your squares. And the square root of 144 is 12. Okay, so that last side we were looking for is 12. Okay, so that was a lot of concepts packed into one diagram. Okay, so there is a good review for you. So let's just apply these ideas to solving some problems. Okay. So on page 125, we're going to look at a couple of problems. Up at the top of the page, this one we're going to do in the whiteboard chat, but I want to talk about this one on the bottom. Okay, so this one on the bottom, we have a triangle, GJL, and in that triangle we have a circle inscribed. It's inside the triangle, and it just meets the triangle at those 3 points, right? So you know that where the triangle meets the circle at those points of tangency, you know that we can draw a radius from the center of the circle to that point, and that's always going to be a right angle, right? Because the radius always meets that tangent line at a right angle. So here's something that's also a very cool thing to know. Remember, this point is always, if you drew a line to that vertex, it's going to bisect the angle. The angles are going to be the same, right? This angle is going to be the same as this angle. And we already know that this angle is the same as this angle. And we already know that this length is the same as this length. And anyway, we could prove, but we won't, that these two triangles are congruent, right? They're like two back-to-back triangles that are exactly the same size. What that means, you guys, is that if the length of KL on this side is 7, the length of, what is that, IL on this side is also 7, okay? These sides are going to be the same length. They're matching. And the same thing happens for the other triangles, okay? So if we look at JH and JI up here, again, that's kind of like two identical triangles back to back. And so if this side is 5, this length over here is 5, because of those will be matching, right? Those will be congruent. And what do you think happens with that last part over there by point G? Exactly the same thing happens. From G to K and from G to H are corresponding sides of these two congruent triangles. So if GH is 3, then GK is also 3. Okay, so notice the pattern, right? If this is 3, this is 3. If this is 5, this is 5. If this is 7, this is 7. So the question is, what is the perimeter of this whole big triangle? Well, we have a 7 and a 3 and a 3 and a 5 and a 5 and a 7. All we have to do is add them up. 7 plus 3 plus 3 plus 5 plus 5 plus 7. And if we add them all together, it's 30. Okay, so that's another important concept to remember, is that when you have a point with the lines of tangency, the distance from the point to each of those tangent points is going to be the same distance. Okay, so those are all things that we've already seen, and this is just reviewing all of them. So let's move on now to page 129. And this is going to be what you did in the Desmos activity. So this should go pretty quickly, you guys. All right, so we're talking about inscribed angles and central angles. What is a central angle? A central angle has a vertex at the center of the circle. That's why it's called the central angle, okay? Central means center, okay? Inscribed just means it's inside the circle, so that just has a vertex on the circle, okay? So here's what that means. And I have already in advance measured these with my handy-dandy protractor. So I'm just going to give you the answers, all right? So if we're looking at angle ADC, that's this pink angle here, okay? I can tell you that that angle measures 40 degrees. I measured that with my protractor, okay? So if I were to measure that with my protractor like this, and I look at where that goes, it goes out to 40 degrees right out here, okay? Do you remember in the Desmos activity what that meant about the inscribed angle? So that's cutting off this arc right here, okay? That central angle is cutting off just this piece of the circle. We're not interested in the rest of it. This inscribed angle is cutting off that same arc. And the pattern was, whatever the central angle is, the inscribed angle that intercepts the same arc is exactly half. So it's going to be half of 40 or 20. All right, so let's see it again. Here we have angle ADC. From the center, it's a central angle, okay? So it's cutting off this arc, ABC. And then we have our inscribed angle from point E here. That's going to cut off exactly the same arc. So if I told you that angle ADC, the central angle was 64 degrees, you would know that the inscribed angle that cuts off the same arc of the circle is half of that, or 32 degrees, right? Once you start doing this, you see how easy it is. They always fit together, half and half, okay? Or double and double if you go the other way. So what if I gave you the other information? What if on this one, what if I told you that we knew this angle? What if I told you angle AEC was 62 degrees? Okay. Then what is the central angle going to be? So that angle is cutting off this arc out here, okay? And if we look at the central angle that cuts off the same arc from the center, that's going to be the radii that go to those same points. And that arc, that angle, is going to be twice as big as the inscribed. So it's going to be 124 degrees, okay? So if you know one, you know the other one because it's either half or double, right? So look at D. And we have to be careful about what arc we're looking at, okay? Because they're talking about arc ABC. So see how that's this arc that goes like this, A to B and all the way around here, okay? So the central angle here, they're not talking about this side of the angle. That would cut off this part of the circle. They're talking about this angle that goes around that way. Okay, it's going to be more than 180 degrees. Okay, so if I told you that that angle was 220 degrees, which is a little more than 180, and you can see that, then what is this inscribed angle going to measure that cuts off that same arc of the circle? Well, it's going to be half of 220, which is 110 degrees, okay? And so that's how inscribed angles and central angles are related to each other. All right, we're going to do one last bit here. And that's basically just filling in some notes. Okay, so here are our notes, and this is going to be just about the end of the lesson. Okay, so what is the pattern? The pattern is the central angle is always 2 times the inscribed angle that cuts off the same arc. Okay. Okay. And the measure of the inscribed angle is 1/2 times the central angle. Okay. So it goes either direction. All right. Final practice, because you're going to see some like this, so I just want to go over this super quick. So if we know that angle B up here is 32 degrees, that's our inscribed angle, right? So then we know that the central angle is going to be double that, right? So we know this angle here is going to be 64 degrees. Unfortunately, that's not what they're asking. They want to know how big is this angle here. Okay, they want to know that angle. Well, here's the thing, you guys. This triangle is made up, it's got 2 radii, right? So 2 sides are the same. It's isosceles. So that means these 2 angles, this has to be the same measure. Both of those angles have to be the same x. So we know they add up to 180, right? We don't care about that anymore. We're just looking at this triangle. So we know x plus 64 has to be 180, right? So 2x has to be 116. And then you would just divide by 2, right? And half of 116 gives you x equaling 53. All right, so you're going to see some problems where you might have isosceles triangles, and you have to remember that that means that 2 of the angles are going to be the same, okay? So off you go to whiteboard chat and your exit ticket, and I will see you in the next lesson. Bye.